We have talked in the past about using synthetic division as a very useful way for finding oblique asymptotes. But in this video, I just want to cover how we're going to do the same thing using long division. Some people are more comfortable with long division, and sometimes long division is actually a good choice because synthetic division can become a little complicated in certain situations. So I'm going to do a simple situation first here, where I have this x squared minus 16 divided by x plus 5. The result of this division will be our oblique asymptote. So the question here is, we're going to focus on the power functions, okay? X squared divided by x. What do we get from that? X squared divided by x is just x. And now we're going to multiply x back down by x plus 5. And that gives us x squared plus 5x. You might recognize part of this from your long division days back in 4th grade or whenever. Now, I need to subtract this thing. So I'm going to subtract this x squared plus 5x from x squared minus 16. Okay, so we're subtracting this. X squared minus x squared is just 0. Negative 16 minus 5x is going to be negative 5x minus 16. Okay, I'm going to keep the x's on the left. And now the question is, we start all over again. What is negative 5x divided by x? Okay, that's our next question. So that's pretty easy. That's just minus 5. Okay, and at this point, I can stop. I don't need the remainder. If you're curious, you could go ahead and figure out the remainder. Right, we multiply everything back down. We get negative 5x minus 25, and we would subtract this part to find our remainder. But it's not necessary. This is just for curiosity's sake. Looks like we would get positive 9. So our remainder would be 9. I don't care about remainders. The oblique asymptote is simply y equals x minus 5. Okay? So let's move on and do, this one looks terrible. How about that? Let's just get started on this one. So I have this big division to do here. 5x squared plus 8x. It'd help if I wrote the right one in here. Okay. 10x cubed plus 13x squared plus 3x. The top of the fraction goes under the division bar. And then what we're dividing it by goes off to the left. So this is 5x squared plus 8x minus 4. Now this may be a little intimidating because these things are so big. But one nice thing about long division is it doesn't matter how big your polynomials get. We're following the same method. And there's no ifs, ands, and buts, and tricks, and things like sometimes you get with synthetic division. So I'm going to go through the steps here. What's 10x cubed divided by 5x squared? Okay, that is going to be 2x, I think. And now I'm going to do the same thing as before. I'm going to multiply 2x by this big polynomial. I get 10x cubed plus 16x squared minus 8x. And I'm going to take that whole thing I just found there, and I'm going to subtract it. Okay, so what do we get? Well, 10x cubed minus 10x cubed is nothing. 13x squared minus 16x squared is negative 3x squared. And then it looks like I've got minus negative 8. That's going to be positive 11x here. Okay, so now I start the process all over again. I say, what is the result of negative 3x squared divided by 5x squared? It's kind of weird. We might have an easier time if we're thinking about this in terms of fractions, right? This is going to be minus 3x squared over 5x squared. Well, those x squareds cancel out, right? So we get negative 3/5. That's the result of that division. And then you could multiply it back through, right? Take that negative 3/5 and multiply it against this guy and see what we get for the remainder. But again, I don't care about the remainder, so why work? Let's just put our answer in. Y equals 2x minus 3/5. This is our oblique asymptote. Okay, and we're all done.